process. So Pete's Jeep Tours offers a popular area. There must be at least 2 passengers for the trip to run, and the vehicle can hold up to 6 passengers. So they're going to define X, your random variable, as the number of passengers, and then we've got our probability table here. So if I were going to find the mean, you guys would know how to do that, and the standard deviation, you guys would know how to do that, right? So here's our mean. You multiply the number of passengers times its probability plus the next number times its probability, right? And we get the mean. What does this mean represent? Yes. Many, many days of passengers. What is this? Yeah. This is your average number of passengers, okay, on the Jeep Tour, 3.75. You guys could make a probability distribution. There's what it looks like, all right? And you've got your variance. There's your formula for variance. Remember, it's the data point minus the mean squared times probability. Next data point minus the mean squared times its probability. And then to get the standard deviation, square root that answer. So I get about 1.09 is how much we typically differ from the mean. So that's all stuff that we did previously. And my mouse just went away. I'm back. Okay. So now let's transform the variable. Pete charges $150 per passenger. Let C equal the total amount of money that Pete collects on a randomly selected trip. Because the amount of money Pete collects is just 150 times the number of passengers, we can write that C equals 150x. Okay? From the probability distribution X, we can see that the chance of 2 people, blah, blah. So what did they do? How did this table change compared to what we just looked at? What happened to those top numbers? We multiplied by what? 150, because it's 150 bucks a person. That's what he's charging. So this was 2 people times 150. This was 3 people times 150. So I could go through and recalculate the entire mean, doing this times this, was this times this, was this times this, was this times this, was this times this. Or there's a shortcut. What did I get in the mean of the original problem? 3.75 was our average number of passengers. How could I find the mean cost? Just multiply it by 150. That would be way easier than redoing the entire formula. So they redid the entire formula for you, or you could just multiply it by 150. Okay, same Z's with the standard deviation. You could redo the whole formula, or you could take your previous standard deviation, which was 1.09, and multiply by 150. So what happened to the shape of the distribution when I multiplied every number, top number there, by 150? Yep, it stayed the same. Your shape's going to stay the same. What do you notice about the mean? You times by 150. What do you notice about the standard deviation? You times by 150. So what you might want to write in your notes, if you're going to multiply or divide by a constant, that will also multiply or divide your measures of center, meaning the mean, the medians, the quartiles, the percentiles. And it will also multiply or divide your measures of spread, including the range, the IQR, and the standard deviation. And it does not change the shape of the distribution. So our histogram shape stayed the same. We multiplied by a constant. All right, how about the variance? So normally we would just multiply by our constant. When you're doing the variance, you can actually multiply by the constant squared. All right, so you might want to add on, for variance, multiply by whatever your constant is squared. So if I was multiplying by 150, I would multiply by 150 squared to get the variance. Because how do I get from the standard deviation to the variance? I square it. Okay, let's talk about adding and subtracting and what that does to the mean and the standard deviation. So, still talking about Pete's Jeep Tours. It cost Pete $100 to buy permits, gas, and a ferry pass for each half-day trip. The amount of profit, which we'll define as V, that P makes from this trip is the total amount of money, C, that he collects from the passengers, minus $100. So we're still multiplying by 150 because that's how much we make per person. But now I have to subtract out my $100 for gas and my expenses to get the profit. So what's the difference in my table here on those top numbers compared to the last one? Should I go back so you guys can look at it? Shifted left. What happened from these numbers to these numbers? Oh, good. We subtracted 100, okay? So for the profit, right, we're making $150 per person, and we're subtracting 100. I could go through and redo all the formula for expected value and for standard deviation, or I could do what to my 3.75 times $150 a person. There's my average number of passengers. And what would the profit be? Minus 100. Okay? So my mean, you can both multiply and subtract. Now, my standard deviation, will it change if I subtract $100? Nope. Okay? Your standard deviation does not change when you add or subtract by a constant because we're talking about the typical distance away from the mean. And if every single number we subtract 100, then the typical distance is going to stay the same. So your standard deviation, you guys, the 1.09 that we got, you only multiply by 150. You don't subtract 100, okay? So the shape stays the same. And here's my new mean. All I did is subtract 100 from the previous mean. And my standard deviation, after I multiply by 150, you do not subtract 100. It stays the same, all right? So notes to add. If you're adding or subtracting, you go ahead and do that to the measures of center, meaning the mean, the median, the quartiles, and the percentiles. But if you add or subtract, it does not change your measures of spread, which is the range, the IQR, and the standard deviation. By the way, how do we find IQR? Yep, just a little reminder. Q3 minus Q1. Do you guys remember how to find Q3 and Q1? So could we write a linear equation for Pete's Jeep tours using the random variable X, number of passengers, that would show the total profit if he charges $150 per person and had $100 in expenses? So V is what they said profit was. And so if I want to do that times the number of passengers, my total profit is going to be 150 times X minus 100. So that's a linear equation that represents what we just did. This only works for the mean. Okay? So here's what the formula for linear transformation is on your random variable X. So you can multiply by B and add A. Okay, the probability distribution will have the same shape. Now, make note of these lovely symbols. What does this symbol mean? Mean. So I can multiply the previous mean by B and add A. What does this symbol mean? Standard deviation. Notice they only multiply by B, and it's the absolute value. Because standard deviation is a distance away from the mean, you're never going to have a negative standard deviation. It will always be positive because we're talking about the typical distance away from the mean. And most importantly, did they add A to this? No. Don't add or subtract from the standard deviation. Okay. So let's put it all together. The baby in the bathwater. One brand of bathtub comes with a dial to set the water temperature. When the baby-safe setting is selected and the tub is filled, the temperature X of the water follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. So define the random variable Y to be the water temperature in degrees Fahrenheit. So notice they gave you the mean and the standard deviation. We also know it's normal. So remember, we could write this normal 34, 2. Okay. So find the mean and standard deviation of Y. Using this formula, if I want to find the mean of Y, to convert my degrees Celsius, and I'm going to plug it into this formula. Do we do both steps? Will we multiply and add if we are doing the mean? Yes, we will. That's really the only important thing. And my answer is 92 something. So we get 93.2 degrees Fahrenheit for our mean. Now, when I want to transform the standard deviation, which was 2 degrees Celsius, I'm going to plug it into my formula, except I only do part of this formula. Which part am I going to do? Yep, and do not add 32. And so I get 3.6 degrees Fahrenheit, because we never add or subtract for the standard deviation. Okay? Now let's do part 2, and this is going to come up a lot. We're going to start doing these types of problems. According to Babies R Us, the temperature of a baby's bath water should be between 90 degrees Fahrenheit and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby safe setting is used meets the Babies R Us recommendation. So, because it is a normal distribution, they told us that in the problem, we can use our calculators. So you guys grab your calculators. You must write norm CDF. You must write lower. And what is our lower bound in this problem going to be? It's going to be 90. And what is our upper bound going to be? Right, because we want to know our chances of it being from 90 to 100 degrees. We just calculated the mean in Fahrenheit, and these are in Fahrenheit. So my mean's 93.2. Whoops, 93.2. And my standard deviation is 3.6. All right, be sure you label these. And anybody got a decimal answer for me? Okay, so there's about a 78% chance that the bath water is going to be between 90 and 100 degrees Fahrenheit. Make sense? That's the samesies. All right, let's see if we get it. So I'm going to call it you. You can tell me if you understand, hopefully. So this is the cars sold problem every Friday in the first hour of business that we did the other day. So we've got the mean. That's what we found when we did this yesterday. And we've got the standard deviation, same numbers as yesterday. Suppose the dealership's manager receives a $500 bonus from the company for each car sold. Let Y be the bonus received from car sales during the first hour of a randomly selected Friday. Find the mean and standard deviation. So we're getting a $500 bonus for each car sold, and 1.1 represents the average number of cars sold. So our new mean, so this time I'm doing the mean of Y, because we're talking about it with the bonus. Okay. And so, Pat O, what do I do to get the new mean? Yep. Multiply your previous mean by 500. All right, and my standard deviation. Grant, what am I going to do? 500 times my previous standard deviation, right? Easy enough. Okay, so there we go. My new mean is $550. This is the bonus mean, and my standard deviation is 471.50. Okay, so to encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit T on a randomly selected Friday is what? Find the mean and standard deviation. So now I'm doing mean of T. So it was 500 times 1.1, and that n, what else am I going to do to the mean now? Exactly. I'm just going to subtract 75. Okay? And Claire, my standard deviation, what am I going to do? Should I subtract 75, though? Good. So the standard deviation does not change from our previous answer. Stays the same. You don't subtract 75, but you do subtract 75 from the mean. So here's my new mean, because I spent $75 on donuts, so I subtracted 75. And and my standard deviation stays the same for any addition or subtraction. It will not change the spread.